Hello, and welcome to the Artificial Intelligence course offered by firstmentor.com. First of all, I want to congratulate you for taking your first step into this enormous world of AI, and I'm glad you chose us for starting your amazing journey. I'm Rohan Kalikar, and I'm gonna be your instructor throughout this course. So, a little about me. I have completed my bachelor's degree in mechatronics engineering, and I went on to pursue my master's in technology management from University College London. I was always fascinated by new and emerging technologies, and my first real interaction with AI was during my master's dissertation. So, now that you know me, let's get started. So, the aim of this AI course is to introduce what AI is, guiding you through the aspects, terminologies, explaining important concepts up until a point where you won't even realize that you're working on hands on projects. This course is divided into modules, and each module is divided into topics. During the entirety of this course, you'll get a chance to work and get your hands dirty on projects which I'll be doing with you. So don't worry if you are a complete beginner in programming. This program is developed to get you started from scratch. Alright, so let's begin with the first module, which is Introduction to AI. And here is the list of all the topics that will be covered in this module that range from what AI is, understanding AI. Then we'll talk about the examples and applications of AI. We'll go through the basics of AI, the types of AI, what are the difference between artificial intelligence, machine learning, deep learning, and data science. We'll also talk about the concerns and issues that lie around this world of AI, and we'll also talk about the future of and with AI. So, take a moment here and try to think what artificial intelligence means to you. I'll wait. So, what do you imagine? What do you think AI is? Yeah. Okay. So, I'll give you the definition. So, the technical definition is algorithms that are enabled by constraints exposed by supporting models, which are targeted at loops that tie thinking, perception, and action together. You certainly did not imagine this, did you? So you can say that this definition is certainly the same as this. Yeah, this is Greek. It's the same. You don't even understand this, you don't even understand this. It's the same, right? So just remember this simple definition. AI is the simulation or copying of the process of human thinking using machines and special computer systems. Simple, isn't it? So it essentially has an umbrella of advanced technologies uh, that lies under this realm of AI. So which are so here we have the whole bubble or umbrella of artificial intelligence. We have machine learning lying at the center of it. Then we have data science, which is an integral form of all the technologies that complete data science. And we have deep learning, which is at the core of all these technologies combined together, right? So now let's dive back to the past to understand the history of where it all began. So the foundation of AI dates back to the 1940s when Alan Turing broke the encryption of the Nazi encryption machine called Enigma, and they went on to win the World War II. He then went on to publish his research called Can Machines Think in 1950. If you haven't already, I urge you to watch this movie called The Imitation Game, which stars Benedict Cumberbatch as Alan Turing. It is an amazing movie, and you'll get a lot to know about this enigma and what lies in the world of encryption and how AI got started. So to determine if a machine can be stated as intelligent or not, we use something called as the Turing test, and this is how it goes. For example, uh, let's say we have two test subjects, A and B. Where A is a human and B is a computer, and we also have C, a human acts as an interrogator or a judge and has interactions with both A and B. If C is not able to distinguish between A and B of being human or a machine, we can say that Turing test made us believe that B is a human. Hence, B can be termed as an intelligent machine. Simple, right? It's quite simple. So, since the 50s, we have seen an enormous rise in the development of such expert systems. And now we have shifted the use of the word intelligent to the word smart. And currently, we are living in the age of smart everything. So now let's come to the second topic of this module, where we understand more about this technology. So the AI space has seen an enormous growth in the past few years and is changing constantly. And I understand that it can be overwhelming to get started into basics at this point, but trust me, it's not. With the right knowledge, approach, and information, it is likely that you will excel, be it AI or any other field. So obviously, it is important that you keep yourself continuously updated with the current industry trends. With that said, AI is not just an important topic, but the most important one because all industries are shifting more and more to advanced and smart solutions in their workplace. So why should we hold back? AI is quite a broad term for many applications in our day-to-day, but it is definite that we don't often realize that it's AI. The most important thing that you should have to realize is that AI is definitely not just robots. It's not just robots, it's so much more than that, which we will talk about in the next topic. So, as we have now established, AI has many forms, so it becomes increasingly important to think about the critical categories that shape this field. And let's go on to the next topic. So now let's talk about the applications and examples of AI. So first, let's talk about the applications. You may pause this video for a while and write or think about all the major fields that you can that AI has in their business activities. Yeah. So here's a list of all the major areas. All right. So let's zoom in a bit. Okay. There we go. So first, let's talk about astronomy. So as we know, the universe is very complex, so it can make sense to make the use of AI to solve such problems like how the universe works and what is the origin of the universe. Now, in healthcare, AI is helping the healthcare facilities by providing better and faster diagnosis of diseases like cancer. And as we all know how important a role AI has played in the pandemic in the rapid development of the vaccines, right? So coming to gaming, a lot of you gamers would want to know that most of the games use AI to predict your moves and run the scenarios based on your play. Although a lot more development is actually needed, and yeah, the most basic example of this is chess. Although not really a game, a computer is able to play such strategic games where endless possibilities exist, right? So coming to the transport application, uh, we can say that AI is capable of doing various travel related works, such as from making travel arrangement to suggesting the hotels, flights, and best routes to the customers. Travel industries are using AI powered chatbots, which can make human like interaction with customers for better and fast response. So coming to the education part, uh, a great use of AI in education is an automated proctor or invigilator for online exams. You all must have been doing a lot of online exams, and you must have had experience with such a proctor or invigilator. It can also be used to automatically grade papers and could be a great doubt solver, right? So if we come to the e-commerce part now, remember how Amazon and Flipkart recommend you products based on your previous orders? And their automated customer service. Yes, AI. Everything is AI. So coming to the agriculture, although not very prevalent in India though, but AI is helping a lot of farmers to monitor the soil and crop quality along with predicting their yields for better cultivation. So after agriculture, we come to the entertainment part. Netflix and chill. Yes, the Netflix part of it, it's automated to recommend you movies and shows based on your likes. And well, yeah, then robotics. Well, this one's quite obvious. Humanoid robots, robots that can make use of machine vision. Uh, yeah, to sort out for like faulty items in manufacturing plants and during the manufacturing processes are some of the examples. In the automotive, I'll just say one word: Tesla. That is it, Tesla. We talk about social media now. AI is used to firstly manage and organize billions of gigabytes of data generated annually, monthly, daily, weekly, whatever you can say. It is also used by companies like Facebook and Twitter and Snapchat to identify latest trends, track hashtags, and also perform sentiment analysis. Sentiment analysis is one of the most important applications of AI, and we'll see if we can cover that out. The next is data security. So in this era of big data, it becomes quite crucial, to protect users' data and privacy. So this is done with the help of AI. So coming to the final part, which is finance. So this is the most important application of AI, remember guys, as banks and financial institutions are harnessing latest technology in applications like fraud predictions and algorithmic trading. And machine learning is used to generate financial forecasts, right? Okay, so just remember that this is just a list of applications that I have found out with my research, but this obviously is not an extensive list and it goes on, it has many applications. Alright, so let's go to the next part. We'll now talk about the examples where AI is or can be used, which brings us to the first example, which is manufacturing robots. So as discussed in the previous slide, these robots are basically systems that aid to detect faults and act on them. AI in this case is used to identify if and when a system might break down by analyzing sensor data, which obviously helps larger companies save literally millions. You won't believe if there's a fault in a machine which is not rectified, a breakdown can lead to a factory being closed for several weeks or even months. So the next example is self-driving cars. Now let's take a deeper look into these. A Tesla, yeah, a Tesla, especially when on autopilot, uses sensor and GPS data to take appropriate decisions. Not only that, it uses its these correct decisions that it just made, to learn and make even better decisions with them to predict as well as avoid crashes. Machine learning, complete machine learning. So next we have smart assistants. Now these ones you definitely know. All the smart assistants like Google Assistant, Siri, Alexa, Cortana. Oh, by the way, I apologize if I turned on all your devices by saying this. So all these work on something known as natural language processing or NLP, which we'll talk about later in this course. Don't worry. Yeah, alright. So here we go. So the next example is proactive health management. So what do you mean by proactive health management? Oh, we will also cover another example called disease mapping along with this. These both go hand in hand. So the best example of this is IBM's Watson for oncology, which is basically an expert system developed by IBM long back, which is used for providing healthcare workers with hidden information from a diagnosis, which may sometimes be missed for cancer patients, which is extremely and crucial for saving the lives of these valuable patients, right? If you want, you can make use of online resources to get more deeper analysis on what IBM has done with its Watson for oncology. Yeah. So the next is automated financial investing. Now, those of you who invest in stock markets will know this, that there are a lot of fintech solutions that essentially make a portfolio based on the stocks that currently perform well. And if you invest in that portfolio, you can invest in the best stocks that the AI predicts. And uh, guys, we have had a lot of chat on these next examples, but now I want you to provide me with the examples from your memory. Okay, so we have virtual booking, travel booking agent, we have social media monitoring, we have inter-team chat tool, we have conversational marketing bot, and we have natural language processing NLP. You can do a little bit of research on this, but we will definitely cover this in the upcoming chapters, in upcoming modules. So I want you to give me some examples on these five, which is virtual booking agents to NLP, natural language processing tools. All right. Let's talk about some of the basic concepts of AI to appreciate the know-how of its critical properties. So now, can you guess what is AI? And also, can you think of what isn't AI? That's a very tricky and complex question. It's not a very easy question, okay? And the answer is it's quite interesting. The answer is there is no answer. Hmm? So there is no commonly agreed definition. You have to define it in the way that you understand it. Yeah, it's as simple as that. No one can come and uh, teach you, tell you what exactly is. Yeah, you have to understand it on your own and perceive the meaning of it and carry on with it. Okay. So when you think of its examples and applications, what seems easy is actually pretty hard, and what seems hard is actually pretty easy for an AI system. Just remember this statement. Just remember this. It's actually a very important statement. Okay. So now what I actually want you to do is look around, pick up an object, any object, and think of what processes did you perform. Think very precisely. The exact processes that you perform while picking up that object. Okay. Okay. Keep holding on to it. Keep holding on to that object. Okay. So yeah. So okay. So the two statements that we just made. First is it seems easy, but it's hard. Okay. So see, I pick up this object, this Google Home Assistant. Okay. But I used my eyes to scan the table first. I looked around. I saw what items I could pick up, items are pickable, what items are suitable to pick up. Yeah. So I chose this one. I planned my trajectory. I planned a track through which I should pick up that object and bring it to my hand. And finally, I moved my hand by contracting the right muscles, my arm, my biceps, my elbow, my wrist, and finally, to squeeze the object with the right amount of force, I had to perform all these activities to hold it between my fingers. Now, this looks like a pretty simple process, but it is difficult to appreciate the complexity that a machine has to undertake to perform the same process. Like, for example, you think about programming a complex machine, a machine that actually has mechanical arms and uh, synthetic fingers to pick an object. You think about the level of programming that has to go into it to perform just this simple task, which you do it within microseconds, milliseconds, whatever you call it. But on the other hand, what seems complicated to us, like playing chess and solving complex math problems, it is pretty easy, actually pretty easy for a machine to compute. Okay, so the reason is that a machine is able to easily apply strategy and rule-based solutions, and that is how an AI system beat Gary Kasparov, who was the reigning chess champion in the 1990s, so long back. Funny thing is that it was difficult to pick up the pieces than to decide on the moves for that AI system, right? Like what I mean is, if I asked you right on the top of your head or on the top of tip of your tongue, what 3 million times 450 is, you don't know, right? So I just, if I just ask this, okay, Google, what is 3 million times 450?
The answer is 1,350,000,000.
That's it. Yeah, that is it. Okay, so let's move on. So now we'll deep dively, uh, dive deeply into the terminologies that are a very integral part of learning AI. Okay, the first and the foremost thing is an agent. So basically, an agent is a system or software program which is directed towards a goal. We define a goal and it does everything it can to reach a particular goal, which is called an agent. For example, a bot, an assistant, or droids. It's as simple as that. Okay. So the next thing is an autonomous robot. So an autonomous robot, which is a truly autonomous robot, is free of influence and is able to control itself without any human intervention. That's it, nothing else. The next thing is backward chaining, uh, which basically means working backwards in an algorithm or a process to find the root cause, find a reason or the root cause of the problem. So you could say that this is like reverse engineering. You de-engineer something to find what is wrong in the root of it, right? The next thing is Blackboard. Blackboard is nothing but the memory that is used for communication between cooperating systems. So it's like a pool of where systems interact and the memory which it is stored in, right? Environment, pretty easy to understand. It is a part of the real or computational world. So for example, this Google AI, this Google Assistant, the table is its environment. Okay, but in a very broad sense, uh, or you can say a very narrow sense, the internet is its environment, right? Because this table is its real world and the internet is its computational world. Okay, so forward chaining, the exact opposite of reverse chaining, backward chaining. So it is working forward to get a conclusion or a solution based on the problem. Okay, now we'll talk about heuristics. It is the knowledge based on T and E, experimentation and evaluation. Okay, we'll talk about this T and E at a later point of time. It is not very important to understand it at this point, but if you are eager enough, I urge you to look into it while you are studying. Okay, the next is knowledge engineering. So, knowledge engineering is nothing but acquiring knowledge from human experts or resources. For example, how do you think this Google Assistant has learned how to say words? Humans have trained the bot, right? It's us humans who have given it our information, and now it has learned more on it, which is knowledge engineering. Okay, percepts. It is the format in which an agent obtains the environment's information. It's quite easy to understand. It is basically a format. Uh, for example, if you in the latest versions of these assistant, if you ask them, tell me what song am I playing, so which is a percept, and this is the format in which you are feeding it information and you're getting your expected response. The next is pruning. pruning is a very important part when you are dealing with data or models, and it is used, pruning is used for improving your data by reducing the noise. Noise is anything which is not needed, any information which is extra and it's just consuming your space and takes a lot of time to compute it. So rule, yeah. So it is the format of representing knowledge base in an expert system. So which also goes by if else then these statements. If you are good at programming, if you know basics of programming, then if else then these kind of terminologies are stated as rules in the terms of AI. So Shell is a software that aids in designing interface engines, uh, knowledge base and UI user interface of an expert system. Shell, you can remember Shell is a software where you program your AI. So task is pretty simple to understand. It's a goal that an agent tries to accomplish. Simple. Any task, not just the end goal, the goals in between. The goals in the nodal part of any network. Nodes are any stop points, any milestones, right? Milestones. You can remember as milestones. So Turing test. We have gone through Turing test. If a system is intelligent or not. That is it. These are the terminologies you should know. Pause this. Take a note of this. Very important. So the next topic that we have here is types of AI. Now, essentially, there are AI is categorized into two types, type 1 and type 2. Okay, so type 1 consists of narrow AI, general AI, and strong AI. Okay, now type 2 consists of reactive machines, limited memory, theory of mind, and self-awareness. So these are the basic types of AI. The lies in the type 1 and type 2. We'll have a deeper look in the coming slides. Okay. So first let's talk about the type 1 AI, and we have narrow AI. This is also called as artificial narrow intelligence. Okay. So it is type of AI which is able to perform a dedicated task with its intelligence. It is currently the most abundant AI in the world right now. All the AI that you have or you perceive or you see right now is all covered under narrow AI. Even these assistants, your smart chatbots, anything that AI is currently under narrow AI. Okay, it is bound by limitations and the scope of its field. For example, if you train a chatbot, for example, if Amazon has a chatbot and you train it to recommend you products, it will only be limited to recommend you products based on Amazon's scope and its products. It won't suggest you Flipkart's products, right? That must be clear enough. Okay. So yeah, obviously it is trained for one specific purpose, and it is also known as weak AI. Okay. Examples are an AI bot that plays chess, virtual chess in this case, purchasing suggestions on Amazon as we talked about, speech and image recognition. Now, image recognition can be stated as Google Lens or Google's reverse image search, if you guys know about it, and obviously speech, these assistants. Siri, Alexa are covered under the speech category, and other assistants are a really good example. Now we'll have a look at a little snippet of Siri. What can I help you with? Nothing, just narrow AI. So the next type of type 1 is general AI or artificial general intelligence. Okay, so it is an AI which is able to perform any tasks with human-like intelligence. Now, do you think these kind of systems exist? Do you think there are systems that have human-like intelligence capabilities? So yeah, they think like a human on its own. Yeah. As of today, no system exists that could match this level of intelligence. Okay. So we currently don't have any system that matches human intelligence. This is also known as strong AI or deep AI, deep artificial intelligence. Okay. So quite a long time back, Fujitsu built a supercomputer called K, which is the closest that we have reached to attaining or obtaining uh, general artificial intelligence. But it takes 40 minutes to compute a second worth of neural activity. For example, if you think of, say, a word or a color or a number, or if you want to um, have signals put in your neurons, the amount of time that your neurons would take 1 second, the computer will take 40 seconds to compute, which is really a long time. Okay, now let's jump to the third type, which is super artificial intelligence or artificial super intelligence. So the level of intelligence in which machines could surpass human intelligence is termed as super intelligence, super intelligent AI. Okay, it has the ability to think, reason, solve, make judgments, plan, learn, and communicate on its own. So it doesn't need any human intervention or any human supervision to work. It is at par with super intelligence, human intelligence, and it is still a hypothetical concept and dazzled by sci-fi movies. So whatever the sci-fi bots, robotic creatures that you have seen on movies or shows, it's all hypothetical, and obviously it lies under super intelligence. So you must remember Ultron from Avengers: Age of Ultron. So it was basically a self-aware and highly intelligent supervillain robot, or in this case, a synthezoid. Okay, a synthezoid. So obviously, where do you think we are now in the realm of type 1, which is narrow, general, and super intelligence? Where do you think we are? Narrow, general AI, or super AI? So I think this our intelligent drone will tell us where we are right now. We'll see where it lands, and that's where we are right now. Okay, let's see where it goes. And here it goes. Okay, and yes, we are currently in the realm of narrow AI. And obviously, we have a long way to go to reach super AI. Even general AI is quite yet not attained yet. So we'll reach there in a few decades, maybe. I wouldn't say years, I would say definitely say decades. Okay. Alright. So let's move on to type 2, which the first category we have is reactive machines. So it is the most basic type of AI. Any AI that you see, reactive machine. They do not store memories or past experiences. They do not store any sort of experiences, and hence they definitely don't fall under machine learning, because machine learning is based on the concept of storing memories and learning from those experiences, right? So these focus only on the current scenarios and react with the best possible solution. Okay. Google's AlphaGo is the best example for a reactive machine. The second is limited memory. So this type of AI can store, or this type of machines rather, can store past experiences or some data for a short period. They can use the stored data for a limited time as well. So there's a difference between these two sentences. The AI can store past experiences or some data for a short period of time, and even it is able to use that stored data for a limited time. Okay. So the best example for this type of limited memory machine is a self-driving car. So, for example, you are in a Tesla, and when you are going forward or on the road, the your Tesla records the recent speeds of the cars nearby you, your distance from those cars, and as well as the speed limits that it can see on the signboards in front of it, right? In its spectrum of vision. Now, when you are past that point, whenever you have crossed that point, the car no longer needs that information, because it's not going to go back in that exact scenario, in that exact point, uh, in this environment or in this matrix, whatever you call it. But so it doesn't exactly need to store that exact information, those exact coordinate, and hence it deletes those memories, but it obviously learns and stores what it has learned and what is necessary, not everything. which is limited memory. So the third category what we have is theory of mind. Theory of mind AI can understand human emotions, people, beliefs, and can interact socially like us humans. Okay, which seems pretty straightforward. But no such machine has yet been developed. Okay. Fourth is self-awareness. Self-awareness is basically the future of AI that we are trying to get into, we are trying to achieve. And superintelligence will enable AI systems to have consciousness, self-awareness, and sentiments. It will be behaving like humans, and we won't be able to distinguish it from a human, right? So it can go smarter than the human mind, but it is obviously still a hypothetical concept. So don't let sci-fi movies or shows fool you. We have a long way to go. We have long decades to go. Not even years, decades. Okay, let's move. In this next lesson, we are going to learn the differences that lie in artificial intelligence, machine learning, deep learning, and data science. So let's take a look at those. Okay. So first we have is artificial intelligence. We have established a lot of information based on AI, but let's summarize it more. So AI deals with knowledge presentation, reasoning, and problem solving. I hope you get this definition. It also deals with planning, learning, natural language processing, motion, and manipulation. All the things we talked about. Planning, picking up that object, learning about the environment, natural language processing, it understands human speech and text, motion and manipulation. Motion and manipulation. Okay, clear. It also deals with social and general intelligence as a whole, not the general AI, it's just general intelligence. Okay. Yeah, so next is machine learning. So basically machine learning is supervised and semi-supervised learning and unsupervised learning. So these are basically the three types of machine learning that we have. Supervised is basically when it requires a human to intervene in throughout its process. Semi-supervised is obviously it is self-explanatory that there is some sort of intervention which is needed, and unsupervised machine learning is you run an algorithm on a model which runs itself, and is able to make decisions. These are real concepts and they exist. It's not like the super intelligent AI that doesn't exist. It does exist. There are lots of models and algorithms that are covered in these three categories. Okay. Uh, the next is reinforcement learning. So which is basically where data is collected, uh, filtered, analyzed, trained and tested, and the algorithm is able to make predictions. Okay, so you have a set of data. For example, a company wants you to make decisions based on its how to increase the number of customers in its stores. So basically, you collect their past data. You look at the data. What you do, you remove what data is not required. You remove what sort of product you are not looking for. You analyze the data that you want. You divide the data into train and test data, and based on the accuracy of the models, you make predictions and you test your predictions against your test data. That is what is machine learning. Okay. It's quite simple. It looks complicated, but it is quite simple, trust me. Okay, the next is deep learning. So deep learning is basically an approach to machine learning that mainly focuses on learning data representations rather than task-oriented algorithms. Okay, it is focused on learning rather than doing a specific task. Okay, so if presented as a series of information or a series of data, it tries to intercept the data, interpret the data, and is able to represent what it has learned from it rather than completing a task to what the data is made for. Okay. So to harness, it is to harness deep neural networks. It is inspired by the structure and function of the neuron in the human brain. We'll talk about this at a later point. We will, yes. So basically, how neurons and the neural network in our brain and the nervous system is, that basically is the jolted down point of the basis of deep learning. It is what deep learning is based upon. Okay. And the last thing is data science. It's currently the hottest topic in the job scenario, job market. And yes, it's under the umbrella of AI, as we talked about. It uses sets of tools and techniques to analyze data and extract insights from it. So you have a set of data. All you have to do is analyze and extract insights that could be useful for a business to make informed decisions. So the goal obviously is to uncover hidden patterns from raw data to help businesses reach their goals. And the most important concept in data science is something called as CRISP DM, which is cross industry standard process for data mining. Okay, so it is basically where how data is uh, collected, generated, stored, managed. Models are formed based on those data. How the model could be deployed, how the model could be improved, and uh, this is the process. Okay, let's go move on to the next topic. In this topic, we're going to talk about what are the concerns, issues, and ethics that lie around surrounding AI. Yeah. The first concern. So, what do you think are the concerns that uh, target AI or the development of AI in the future? What cracks up in your mind when you think about these concerns? So, AI requires data, a lot of data. Let's establish this fact that AI requires a lot of data, because obviously to make right decisions it has to have a lot of background information behind it to make that sort of knowledgeable decision. All right. And data is very sensitive. It contains user privacy, it has user information, and as well as the tracking patterns of the user, what a user browses on his or her um, uh, browsers, what his internet history is, all those information. This information is very sensitive, and a company collecting this information has to have very careful about it. The next important concern is bias. For example, if a data that is collected contains a bias, the AI system that is generated based on that data will have a bias. For example, if the collected data has preferences and choices of a selective group of customers, and if a model is trained based on only those data and those choices by the customers, another that data won't be able to generate appropriate recommendations or appropriate solutions for a different set of customers, right? That basically what is bias. And the next concern is safety. Obviously, when data is so important, people are going to worry about the safety and the security of their data. So, what do you think are the possible issues and challenges when we are developing these AI systems or growing in the field of AI? Do you think there are any underlying situations or hidden challenges that you are not able to see right now that would be affecting how AI is developed in the future? So yes, the one of the most important challenges is data scarcity. What if you don't have enough data? What if the data you have provided to the system, provided to the algorithm is not enough? What would you do? You can't, because when a data is collected, it is collected. You can't go back to the past and change or collect more data. That really is an issue, and it exists in the real world. Limited knowledge. What if the problem that you're trying to solve, you have a very limited knowledge about it, or the knowledge about it is very limited in the world itself. For example, not a lot of people know about technologies like cryptocurrency, blockchain. What if another important technology like this comes into existence and the AI system is not able to provide solution because there is not enough knowledge on it? Yeah, it is really an issue. And another issue or a challenge is that if the data is or the system is unreliable, unsafe, or has poor quality outcomes, that is the exact opposite of what we are trying to achieve. We are trying to be able to provide solutions that would better our lives, that would ease our lives. But if they are unreliable, they are unsafe, they are potentially a threat to human life. They are not safe to be used, right? So that is what is basically the crux of it. And what do ethics mean here? Ethics are, what do you think ethics are, and what do you think they mean here? So basically, in the justice system, uh, your rights, your rights as a human being, are they being justified? That is what concerns some of the lawmakers and in the development of AI. So uh, the main target here is AI systems. They need to be transparent, they need to be explainable, and with justifiable outcomes. Now, whenever a company is developing an AI-based solution commercially, it requires it to have uh, there needs to have transparency, which means they should be able to explain why they are going to deploy that solution, why the solution is important for the humanity, and does it benefit the humankind. Is it harmful? If it is harmful for the human being, human race, it should not be created in the first place. Yeah, and that's where rights come into place. What if the data that is generated from you, you don't want it to be generated, you don't want it to be collected? What about that? Because they are required to be morally accountable agents. The AI systems, they are required to be morally accountable agents. Because and there are debates, a lot of debates going on the usability of AI. Even there are current court cases going on all around the world to defend the fact that the future systems of AI would depend on the current data that is provided. But do you want your data to be collected? Do you want your data to be used in the future? Do you want that? That is still a concern, and there are a lot of debates going on. So, what do you think? Is it future of and with AI? How do you think AI will change our future? How do you think it is currently changing us, and how do you think it will change our future? Okay, so the crux of it is AI will change everything. AI is going to change your jobs. AI is going to change how we perform, how we function, how we interact. Uh, just as us humans evolve, the technologies that we develop evolve with us too. We have seen a lot of information regarding to that since the industrial age and the industrial revolution, and we currently are in the industrial revolution 4.0. Who knows what lies in the upcoming 5.0, 6.0 generations of industrial revolution, right? So AI is going to change everything that you see, that how you function, how you do stuff, right? So obviously it will have an impact on plethora of sectors, including healthcare, manufacturing, transportation, education, media, customer service, to name a few. There are a lots of it, and even this screen is quite small to include all of those sectors, right? Because it is going to change everything. So most importantly, that what most of the people are scared about: how will AI change your job? Well, that depends. How routine is your job? If your job does not require a lot of thinking, if your job can be easily replaced by a machine that does not have to think a lot, then yes, that job is going to be taken up by a machine in the first stage of AI deployment in the workplace. But will AI eat up your job? A lot of you are concerned about it, a lot of people are concerned about it, and the answer is yes and no. It is yes and no. Well, you see, you have to evolve your skills as well as update your tools and go forward with the changing world. If you say that the tasks and work, the way of working that I am doing right now, I am not going to change that, then yes, your job will be eaten up by AI because you have not evolved your skills. The more you evolve your skills, the more likely you are going to be able to cope up with that evolved job. Because as we talked about, as us humans evolve, the tools and techniques and technologies evolve with us. So obviously AI won't necessarily take up your job, but it will be an assistant to you. It will help you evolve with your job. You will have your job if you keep up with the change.